Okay. Class, today we're going to try to give you a video for your entrance card. We're going to ask you, given the fact that you have a second derivative of a function, and you have these extra bits of information here, so it's saying that this function f that we want to find, when you plug in 0, your output's -4. And if you take the first derivative of this function that we're trying to find, if you plug in 0, you get 1. And we're going to use this information to figure out what f is. And so we'll start off the way we've done in class is we have the second derivative, so let's go backwards and find the first derivative. So this involves the antiderivative. So what we're asking is, can you tell me what f prime of x is? And so in class today we learned that what we do is we take the power here, the 2, and we decide to add 1 to it. So remember I wrote something like this, add 1. And so we get 60 x cubed, and then whatever we raise it to, we would divide by that. So that one's an easy one. Now here we have a little bit of a tougher one. So we have the sine x. What function, when I take the derivative, gives me sine? Well, it turns out the cosine would be a good candidate, but the cosine gives you negative sine, and we want positive sine. So a better candidate would be the negative cosine, because the derivative of the negative cosine is the positive cosine. Now we have a new function we haven't done with. We have e to the x, but you know that the derivative of e to the x is e to the x. So that means the antiderivative of e to the x is also e to the x. So here the antiderivative is 2 e to the x. Notice that, again, just to make sure that you understand, the derivative of 2 e to the x is 2 e to the x. And finally, this is not the only function. So this f prime, if I take the derivative, I get this. This is true, but it's not the only function that does this. In fact, there could be some constant that we don't know about. And that happens a lot in your work as engineers, for those of you that are engineers. And so our goal is to determine what the c is. And the way we do this is we use this condition right here. And so these conditions up above, they're actually, in most of the work that you do as engineers, they're called initial conditions. They're conditions that happen at the beginning of the problem. And usually these have to deal with, what happens at time equals 0. And so this first one is the one that's going to help us. Actually, sorry, I lied. This second one is the one that's going to help us figure out what c is. So I'm going to write that down. Actually, before I write that down, let me simplify a little bit. So f prime of x is equal to 20x cubed minus cosine x plus 2 e to the x plus c. Okay, so that's simplified. So now, let's go ahead and use this condition right here. So I'm going to go ahead and write it in red. So f prime of 0 is equal to 1. That means we are allowed now to plug in 0 for all the x's here. And when we do that, we should get a 1. So when we do this math, or when we do these computations, we get 20 times 0 cubed minus cosine of 0 plus 2 e to the 0 plus c. And this, of course, according to our initial condition, is supposed to be 1. Well, most of these you can do really easily. For example, this is going to be 0. 20 times 0 cubed, that's 0. So that one we don't have to worry about. And then the cosine of 0, well, you guys know that's 1 now because we've been doing it so much. So this is going to be minus 1, so negative 1. E to the 0 is 1, so 1 times 2 is going to be 2. So I get 2. Then I get plus c equals to 1. And now we do a little bit of math here. Negative 1 plus 2 is 1. And then subtract 1 on both sides, so you get that c is equal to 0. So what this means is that now we can figure out exactly what f prime is. We actually know that the c is going to be 0, so our f of x, or f prime of x, excuse me, is actually going to be 20x cubed minus cosine x plus 2. Okay, and there's no c. So now we need to do this one more time, because remember, our goal is to find f, and we have another initial condition, and we've only found f prime, so we need to find f. So we're going to go ahead and do the antiderivative one more time. And so now, again, I'm going to go backwards here, so I want the function f, and this function f, when I take the derivative, is going to give me 20x cubed minus cosine x plus 2. And so we start with this part, and we know that we take this power and we add 1 to it. And so what I'm going to get is 20x to the 4th. Then I'm going to divide by 4. And that takes care of that one. The next one, what's the antiderivative of the cosine x? Well, if you remember this, if you have the function sine x, the derivative of sine x is the cosine x. So that's a great That's the actual one. And I just realized I made a small mistake. Sorry, no point on this one. This is 2e to the x. Apologize for the mistake. But again, the antiderivative of that is 2e to the x. And once again, what we have here is this function, and the derivative of f, it does give us f prime, but we don't know if this is the only function, so we need a constant. And the constant this time I'm going to call d. I'm going to use d because I've already used c. But again, we're going to use this initial condition to figure out what this is, and the initial condition is f of 0 is equal to negative 4. So f of 0, sorry about that, f of 0 is equal to negative 4. So I'm going to move this up just slightly, and so what that means now is I can plug in 0 for this x's, and so what I'll get is, by the way, 20 divided by 4 is 5, so 5, 0 to the 4th, minus sine of 0, plus 2e to the 0, plus d is equal to negative 4. Okay. Well, you can compute most of these. You know that this is going to be 0 here, and the sine of 0 is 0, and you know that e to the 0 is 1. So when we compute this, we get that 2 plus d equals negative 4, because we know that this will be 0 and this will be 0. Now we solve for d, so you subtract 2 on both sides and you get d equals negative 6. So this means that the function that we were looking for should have been f of x is equal to 5x to the 4th minus sine of x plus 2e to the x minus 6. Now, this is the answer down here. This is correct, but what I want to do one last time is to do a quick check. So I rewrote the problem over here. And so the way you would check is you would make sure that this function that we found, this function f, actually meets these conditions. Is f of 0 negative 4? And is f prime of 0 1? And is this really the second derivative? Those are all the things that we would check. And so we'll do this one by one. So first of all, the blue one is f of 0 equal to negative 4. So let's find out. So when you plug in 0 for x, you get 5, 0 to the 4th, minus sine of 0, plus 2e to the 0, minus 6. And sure enough, notice that we get 0 minus 0 plus 2 minus 6, and this is negative 4. So we can definitely check off this initial condition. Next thing we do is we need the derivative. So f prime of x is equal to 20x cubed minus cosine x plus 2e to the x. Again, this you don't have to do for WebAssign. WebAssign will check this for you, but I want to do this in case you ever have a test. So here we got to check that f prime of 0 is equal to 1. So let's find out. So when we plug in 0, f prime at 0, we get 0 minus cosine of 0 plus 2e to the 0. And notice that, well, 0 is just 0, but cosine of 0 is 1, so we get negative 1 plus 2, which is equal to 1. And so again, we've checked off the second one. So good. Very nice. Now we just got to check that the second derivative really is this guy. And that you can probably see that it shouldn't be too much of a hassle, but just for completion, f double prime of x is 60x squared plus sine x, because the derivative of the cosine is negative sine, plus 2e to the x. I notice that's exactly what we started off with, so we can check that one off, and that means that we've completed the problem. The question was find f, and this is the f here, the f that we wanted. We found it. We didn't even know it was lost, but here it is. That's the f that we wanted to go. And so hopefully this helps you with your entrance card today. There's 3 of these problems. Good luck, enjoy, and I'll see you in class on Thursday.